Okay, now I want to go over the second problem that we had yesterday, and that was where we had Louise, Sally and Stephen going to the bakery for lunch on Monday, and we are putting the information from our question into the matrix. So you can refer back to the PowerPoint presentation and get exactly what's going on, but basically we had that Louise had 2 sausage rolls, 1 donut and a drink. Sally had 1 sausage roll, a donut and a drink, and Steve had 4 sausage rolls and a drink. Okay, so that's Louise, Sally, Stephen. Okay, we had also a matrix that described our costs. Okay, so let's call this one our quantities matrix. And now we'll set up our cost matrix. So our pen has changed. Okay, so the cost matrix is going to be $3.80 at the bakery for sausage rolls, $3 for donuts, and $4 for drinks. So that's our bakery. Okay, and the canteen, we have got $3 for sausage rolls, $4 for donuts, and $3.65 for drinks. So we need to analyse these matrices against our rules. The size of this matrix here is 3 by 3, and the size of this matrix here is 3 rows by 2 columns. Okay, our rule 1 says that for these to be able to be multiplied, we need to have the same number of columns in the first matrix and rows in the second matrix. Okay, and that is true. All right, so that's going to work. And rule 2 tells us that our resultant matrix is going to have the same number of rows as the first matrix, and it is going to have the same number of columns as the second matrix. So we can expect to be creating a 3 by 2 matrix. Okay, now this is what you guys need to do when you're doing your project. You need to analyse your matrices and make sure that they are of the correct order, and understand the size of the matrix that you're going to end up with at the end. All right, so when I actually multiply this, what I have is I go 2 multiplied by 380, 1 multiplied by $3, and 1 multiplied by $4, and I add them all together, which gives me $14.60. Then I take 2 and I multiply it by $3. I add it to 1 multiplied by $4 and 1 multiplied by $3.65, and I put that in the second row. Sorry, the second column. Okay, so that comes to $13.65. Then for Sally, I go 1 times 380, 1 times $3, 1 times $4, and that goes into the second row, and that comes to $10.80. And for Sally again, I go 1 times $3, 1 times $4, and 1 times $3.65. So that comes to $10.65. And then I do it all once again for Steve. 4 times 380, 0 times $3, and 1 times $4 comes to $19.20. And Steve also went to the canteen, $3, $4, $3.65 multiplied by his quantities comes to $15.65. Okay, so that is our resultant matrix. Okay, that is our actual final cost. This one we should really be calling our price. That's a much better word for it. Okay, so our final cost here. Then if we want to find out our total so that we can actually analyse whether the bakery or the canteen is cheaper, all we do is we just add these up. Okay, so we're just going to add $14.60, $10.80 and $19.20, and that's going to give us $44.60 and $39.95 for these ones. Okay, so that's how we analyse that. But the point is that what is still identifiable is that Louise, who is a first row person here, spent $14.60 at the bakery, and Louise, first row, spent $13.65 at the canteen. Sally, who's the second row person, has spent a total of $10.80 at the bakery, and she has spent a total of $10.65 at the canteen. And our man Steve here, he has spent $19.20 at the bakery, and he has spent $15.65 at the canteen. So when we look at matrices, we can think, well, we can just see if we just multiply all those costs and we just add them up, then we'll get the final answer anyway. However, what it is doing is it is presenting it to us in a way where the individual values are still legible to us.